Hi everyone, welcome back. This week we're going to build on the ideas we introduced last week when we covered the p5play library. So we talked about the basic objects that are inside p5play. This week we're going to build on this and we're going to do a more of a fully fledged game example. And the reason we're going to do this is we're going to start to talk about, okay, now that we have these game objects, how do we go from just a demo to something that can play more like a game that has a start, a middle, and an end, perhaps. So we're going to talk about how we can start to structure longer programs as opposed to the short sketches we've been doing up until now. We're also going to cover new concepts from p5play as we go along and do more of these game examples. So today we're going to talk about animations, so adding animations to our sprites. We'll get a bit more familiar with the collisions and also the input mechanisms in p5play. So this is the game that we are going to build this week. I'm gonna start just by showing you what the game is, and then we're gonna go into a new sketch and rebuild it from scratch together. There's gonna be at least a couple of parts to this, and we'll break it up. So this is the game that we're building this week. It's called Zombie Apocalypse. It's a very simple, basic game, but it has all the ingredients we need to get started. So we're going to be presented with a title screen with the title of the game and then an instruction prompt. And then we'll be able to select different player skins. And then once you select the player, some music is going to start playing, and then we get into the game. So as I said, this is a very simple game. The gameplay is you can walk around, you have to dodge the zombies, and over time, more zombies come in. Your score is basically how many zombies you were able to, how many zombies were added to the screen. And as soon as you touch a zombie, it's game over, but you can click to try again. So it does get pretty hard over time, and it's a bit of a pessimistic game because you cannot win that zombie apocalypse. Eventually the screen will get completely filled with zombie, but you can try to survive as long as you can. So that's going to be the game example we're going to build this week. So let's put that aside and go into a new P5 editor. Okay, so like we talked about last week, the first thing we're going to do is we're going to bring in p5play. So p5play is the game engine framework we're using for these examples. And the way that we bring that into our code is we go to the p5play website, we grab these two script tags, and we put them into the index page after the scripts here, as such. Okay. All right, so that's going to bring in these libraries into our code. We can save this, and then we can go back to our sketch. So in the world of p5play, p5play has its own function to define the canvas. So we use new canvas, and we can still use window width, window height for this example. This is a good habit to get into. This p5play canvas has some additional features, like you can set an aspect ratio, for example, and you can do kind of like pixel-based games. And we'll maybe explore that in future examples. And we're going to go and set a black background. Okay, so we'll just double check that their library is imported correctly. No errors, looks good. All right, so the way that we're going to be programming this game is like all the objects we've seen in the game example I've shown you, the player and the zombies, all these objects are sprites in p5play. So we're going to start by creating a sprite for our player object. So we'll say player equals new sprite. Okay. And as you'll recall, in p5play, if you create a sprite, it automatically gets added to the world, to this array called allSprites. And p5play draws, at least by default, draws the objects automatically for us. So we don't have to do anything in draw. There's an extra layer that gets added by the p5play library where these objects get drawn automatically. So this is our sprite here. Now, what we're going to want to do as a starting point is we are going to attach an animation to this sprite. Okay. So in order to do this, we're going to need to bring some asset files into our sketch. Now, on the p5.js editor, this is how we do this. So I'm going to make a folder here because we're going to have quite a few assets for this game. So I'm going to create a folder called assets. Okay. And I am going to go into this folder, and then over here, we're going to upload some files. I'll provide a link in the video description if you want to download these assets for yourself, if you want to follow along. These are all assets that are free from public domain. Okay. So we're going to start by this female player animation, and then eventually we'll bring in the others. Okay. Or you know what? I'm just going to upload everything. So I have an animation sequence for the female player. I have an animation sequence for the male player. I have a font file for the title screen. I have a little song that we're going to use as the background music, and then a little animation sequence for the zombie that's a little bit shorter. So let's just grab all of these files, and we're going to upload them on the p5.js web editor. We'll say upload file, and just grab that and upload them. Okay. All right, we might as well do it all right now. So I've added a bunch of files here in this assets folder, and we're going to start with the female player animation, and then we'll make our way down eventually. Okay. So in p5play, the way that we do animations, let's bring up the reference. We have an animation object that we can use to represent animations. We load them using load animation. Now, there's a few different methods that you can use in p5play to load animations. And just a word of warning, because of the way that the p5.js web editor handles these assets that we upload, we are not able to use this method where we would say, here's the name of the first file, and here's the number of frames that I have in my animation. Okay? The reason for that is the p5play web editor doesn't actually use these file names because the files that we upload here, they get put onto this cloud hosting service. So these actually in practice have a really long kind of name that gets generated automatically. And the editor goes in when we put a file name into our sketch. When we try to run the sketch, there's some kind of behind the scenes stuff that happens, and those file names get replaced by these automatically generated names for the cloud files. Okay. So long story short is that the code in here that's trying to figure out the sequence of files doesn't work because of the way that the files are handled in the web editor. Okay. So instead, we're going to use the second method, which is here's an array of images that we want to see as the image sequence. Okay. And then the last method, which you could explore, is providing a sprite sheet. We may do this in another video, where all the images, all the frames from the animation sequence are in the same image, laid out as a grid, and then you just give the dimension of that grid when you want to load your animation. So that's another method. But we're going to use the array method for this example. Okay, so let's jump back to our code here, and we're going to say, all right, let's create preload. So if you'll remember, preload is a function that we have access to in p5.js when if we load assets, so files that are on the server, like images, things like this, it takes a little bit of time before the web browser can download those. So if we put those loading operations in preload, it ensures that they'll be available to us by the time we reach setup. So it's kind of like a pre-setup step. So we're going to create an object up here. Let's make a variable. Let's call this female player Annie for animation. Okay, someone don't feel like writing the whole word, and we'll start with just a single frame of the animation. So we'll say female player Annie equals load animation. So load animation is provided by p5play, and then we'll pass an array here, and the first element of the array will be the name of the first file in our animation sequence. Okay? So this is the name of my file, and I have to also remember to include the assets folder because that's where I put it. So we'll say fplayer -0.png. Other note, p5.play I think only supports PNG files. So if you're trying to use other formats, you might want to convert your files first. So let's hit play to make sure this is loading properly. And then once we have our animation, we're going to go in setup on our player object, and we'll say the animation of the player object. We'll say add Annie, and we'll say female player Annie. And now we can see that instead of a randomly colored square, what we see now is our frame that we loaded. Okay. Now, if we wanted to get 2 frames, this is an array. So we could put in another frame of animation here. We could go and say, okay, let's go with fplayer1. That's the next frame. And now we have 2 frames. We could put 3 frames. Turns out there's like 9 frames in the sequence that I have. So we could put them all by hand here if we were so inclined. But we know that we're going to have female player, we're going to have the male player animation, we're also going to have the zombie animation, and all of these will have to load in a similar way. Okay? So instead, what we're going to do is we're going to write a little function that's going to automate this redundant work for us. So we're going to write a little function that's going to say, here's a file name, and I want you to create an array of file names, right, with an increasing number in each file, so that we can use this array in load animation. So let's go after draw here, and let's create a function that's going to do this exact job. Okay? So we'll say function. Let's call this function, we'll call it create, let's call this function, it's a good name, image sequence. Okay? So we'll say image sequence, and we're going to put 3 parameters to the function. First, we'll put the prefix. So the prefix is going to be the part of the string up to the number that we want to have here. And then we'll put the number of frames that we want to see in the sequence. So let's say number of frames. And then we'll put the extension. Okay, so let's call this the extension, ext. And just to show you, we can put in functions in JavaScript, we can put default parameters. So if I say .png here, it means that if I don't provide this last parameter, this will be the default extension, which we want to see because p5play only supports PNGs. Okay. All right. So what is this sequence? What is this function going to do? Well, it's going to create an array. Let's call this sequence. Okay? And then using a for loop, we're going to repeat based on number of frames that we want to see. Okay? And then in that sequence array, we're going to put a string. We're going to put prefix plus the counter plus the extension. Okay? And then once we're done with this, we are going to return the sequence we just made. Okay? So let's test this function that we just built. We are going to go in preload. We're going to say, let's create an image sequence. We're going to put fplayer dash as the prefix. We're going to say this animation has 9 frames. Yes, 9 frames. And the extension, we're not going to put anything because we're just going to use the default parameter we provided here. And then we're going to use console log to just print out what this function is going to generate for us. Okay, and here we have it. This function that we made now is going to create for us the array, right, that we need to pass to load animation for a given animation sequence. So what that means is that when we create our other objects down the road, we'll be able to reuse this function every time we need to generate one of these file sequence array. Okay, so it's just a little bit of a time saver here. So this looks good. Let's try it now into our load animation. We'll say load this sequence. Now we can see we have the more fulsome animation sequence that has 9 frames that got loaded over here. Okay. And we could even cut to the chase here. We don't really need this intermediate variable. Now that we know that this is loading, this is generating the sequence that we want to see. I'm just going to put this piece of code here when we call the sequence. We're going to put that directly into the parameter of load animation. And then we can get rid of this intermediate variable. So we'll just cut the middleman here and go put that right into the parameter to load animation. And now we have our animation getting loaded on our player. All right. Pretty sweet. Okay. All right. So one thing to note, let's take a look at this idea here. Let's turn on, we're going to say in setup, we're going to say player.debug equals true. So sprites in p5play have this debug feature where once you turn that on, if your sprite is not just a basic shape like a circle or a square, if you're using an animation, it's going to show us here, this is the collision boundary for our object. So by default here, it's using the size of my image sequence as the size of the collision boundary. So we'll see that this is something that we can tweak after we've added an animation. let's say we wanted to make this a little bit tighter. We could say player.width equals 35, player.height equals 75, let's say, right? So we could make this collision box a little bit tighter, right? So that doesn't have to be exactly the same size as our animation. So let's turn that off. We'll revisit this later when we have a bunch of enemies to dodge and when we're kind of tweaking the gameplay a little bit. Okay. So now that we have our player sprite, let's go into draw and let's start to program our basic player behavior. Okay? So what I mean by player behavior is going to say, okay, what does the player do? Well, first of all, let's give ourselves a little bit more space here. I'm going to toss this to the side. Okay, there we go. It's a bit more spacious. We said we have a behavior where the player is going to follow the mouse around. So let's go into draw and program this. We'll say, okay, player, we'll say move towards mouse. So remember, mouse in p5play is now a new object we have access to that represents the mouse cursor. We'll say move towards mouse, and then here we're going to say 1, which means it's going to cover the entire distance immediately. So kind of basically almost teleport to where the mouse is located. So now we have our player following the mouse. Okay? We could also in our game, we could say mouse.visible equals false, and that's going to disable the mouse cursor. So now basically the player becomes the cursor. So we don't want to have this little arrow on top of our player. Okay. The other behavior we have for the player in the game is that you'll notice when I move my mouse here from left to right, it looks a little bit weird when I move left. It looks like the character is doing a moonwalk here. So we're going to take our animation sequence and we're going to flip it. We're going to reverse it when the player is moving to the left. So we don't need to have a whole separate walking animation. Right? For the left side, it's going to be the same one as the walking right animation, just basically mirrored, right, along the y-axis. So the first thing we have to see is we have to decide how do we know which way the player should be facing. Okay? So to do this, we're going to take a look at the mouse and how it's moving. So the way that we can tell how the mouse is moving is we're going to compare where the mouse is in the current frame, and we're going to compare that to the value of the mouse in the previous frame. And we'll look at the difference between the two. And based on that, we'll be able to decide, okay, you're probably moving right or you're moving left. Or if there's no change, it means you're standing still. Okay? So here's what I mean by this. Now that we're following the mouse, we're going to say set the player orientation. Okay? So we're going to take a look at p_x. So p_x is where the mouse was in the previous frame. Okay? And we'll say if this is greater than where the mouse is currently, right? So if p_x is greater than where the mouse is currently, it means that we're going to the left. Okay? So if that's the case, we're going to say player.scale. So scale is going to set the scaling attribute of the player. We're going to scale on the x-axis, and we're going to set the scale to -1. Okay? This is what's going to happen. So here, if you say if I move left, right, now the player is facing left. Of course, now we're stuck left, so we need code to make us face right again if we are moving in the other direction. So this is going to be if p_x, so this is the opposite basically, right? We're going to say less than, then we'll set player scale x, we're going to set it to 1. Okay? So the -1 here is going to cause the scale x to basically get mirrored. And now, depending on where the mouse is moving, our player is facing in the right direction. Now, there's an interesting thing that happens if I move left and then stop moving. Oh, it actually doesn't change it. Okay, so that's fine. That's actually working okay. Yeah, so the case where if we don't move, right, if mouse x is equal to p_x, well, this is taken care of here because we're only going to change the scale of the player if we have motion, basically, if those things are different. So here, if we don't move, we just leave it alone and we stay in the direction that we were in the previous frame. All right. Okay. So this is this is basically our player object. So pretty straightforward. Now let's talk about bringing the zombie objects into the game. So for the zombies, we're going to take advantage of the group feature of p5play. So groups are p5play's way of managing kind of collections of related sprites. So we're going to create a variable, we're going to call it zombies, plural, just to refer to the fact that zombies is going to be a group. And in setup, we're going to say zombies equals new group. So in p5play, when you create a group, it basically becomes like a little factory for sprites. And it allows you to set a bunch of attributes on the group that will then be transmitted to new sprites that are created from that group. Okay? So it allows us to create basically like a category, or like a little sprite factory is how I like to think about it. So for our zombies, we're also going to need an animation. So let's create an object to store this animation. Let's call this just zombie Annie. There's no player. And if you go into our assets, we'll see that we have a zombie animation that has only 6 images in it. So it's called zombie-0 up to 5. Okay? So just like when we loaded the female player animation, we're going to say zombie Annie. In preload as well, we'll say load animation. We'll use our handy image sequence we made earlier, and we'll say assets / zombie dash, and then we'll say 6. We have 0 to 5, so we have 6 frames for the zombie. Okay? And let's move this a little bit. There we go. Okay, so now we have another animation object that we can attach to our zombies. So we'll say zombies.add Annie zombie animation. Okay. So let's give this a go. We're going to test it out. We're going to say zombies.amount just for testing here. So the amount property on the group, if you'll recall, allow you to automatically say, let's say you want 5 of a particular group, you can just set the amount, and p5play will automatically create 5 objects of that type, okay, and just get created. Now, we can run into them. Ooh, fun times. Okay, so here's our zombies. Now, we have a little bit of work here in terms of setting their different attributes. So let's talk about this. First of all, we could take a look at again, remember we had player.debug equals true. We could also say zombies.debug equals true, and that's going to cause all the zombies to have their outline box, right, visible. So you can see here, if I touch the edge of a block, right, this is triggering the zombie, the physics, right, for these zombie objects. So just like with the player, right, we could also set, using the group properties, we're going to do this after we add the animation, because I think the animation may undo some of this. We'll say zombies.w equals 35, and we'll set the height to 75 also. Right. So now their collision box is a little bit tighter, is a little bit closer to what the sprite actually represents. By the way, this debug feature, one thing that I like to do, instead of doing this on every object in the game, let's make it so that this is something that we can toggle on and off. So we'll go at the bottom here. We're going to implement key pressed. And in key pressed, we're going to use the allSprites object. So allSprites is this array that gets created in p5play, which it's basically a group, a kind of a master group that contains all the sprites that we've made in the game engine. So if we were to say allSprites.debug equals true on the key pressed, you'll see that if I hit a key, now I can turn that on for all the sprites at once. Okay? And what we can do if we want to be able to toggle it is we can use the exclamation mark symbol. What that does is it means not, and exclamation mark allows you to take the opposite of a true or false value. So we'll say allSprites equals not allSprites.debug. Okay, so this is a toggle, which means if allSprites.debug was true, now it's going to become false, and vice versa. Okay, so kind of like a light switch. So now if we press a key, we can toggle, and we can always be able to turn that on as we develop our game and turn that off afterwards. Okay. All right, let's go back to our zombies group here in setup. So a couple of things we could do here. We could say, we probably, in the game that I showed you, I don't really want my zombies to be able to just spin around like this, because it's not called zombies in space. It's called zombie apocalypse. So we're going to say zombies.rotationLock equals true. Okay. And that means that now the zombies can only stay, they can no longer rotate as I bump into them. We could do the same for the player as well. We'll say rotation lock equals true. So now as we bump into these objects, they're running away quite fast. You gotta be careful sometimes with this move towards. They're no longer rotating. Okay. The other thing we're gonna do is we're gonna say when we create a zombie, we would like it to just not always appear in the center of the screen, but just appear somewhere at random on the screen. So to do this, we're going to use the arrow setters of the group objects. So we talked about this in previous videos, but just to recap, the arrow setters allow you to do something like this, where we could say, instead of setting an attribute to a fixed amount, like we're doing for the width here, every zombie has a width of 35 and a height of 75 for the box. We're going to use this syntax. We're going to say the value of x for a zombie is going to actually be equal to this function. So which means when we create a new zombie, a little function will run and it will determine the value of x for the zombie at runtime as the zombie gets created, kind of as the code runs. So the syntax we use to do this, it looks like this. We'll say equal, and then we say function, parentheses, and then we have this little arrow symbol. So it's an equal sign and a greater than symbol, and it looks like an arrow. And then what we follow it up with is something that returns a value. So here we could say the x coordinate will be random between 0 and width. And this is going to randomize the x values of our zombies. And this syntax here will randomize the y values of our zombies. So now we're creating 5 zombies, but they all start in different places. So this is a really, really cool feature of this this group that we can use to define the way our objects are going to behave up front at the beginning of the game. And then as we add more objects to the group, they can have these dynamic properties. Let's do the same thing with the velocities. So the velocity is the speed of an object in p5play. So we'll say the x velocity of a zombie to begin with is going to be equal to a arrow setter that's going to be random between, let's say, -2 and 2. And we'll say the y velocity will be random between also -2 and 2. And now as we create zombies, now they get to start walking in a random direction. Okay. Very cool. Let's create a few more. We'll go up to 10, let's say. Okay, awesome. So now we have some zombies and they're walking around. Now you may notice, unlike our player, right? Unlike our player here, the zombies, they always face, again, they face in the right direction because we only have the one animation for the zombies, just like with the player. So now that we've created our objects over here, we are going to go into draw, and then we're going to, this is the player behaviors, okay? And we're going to do the zombie behaviors. Okay? So the zombies, we're going to program their behaviors. So as a starting point, we want to say when the zombies are walking, we want to set the scale of their animation to be facing the correct way. So what that means is we're going to have to go through all the zombies we have, go through the list, check them one at a time and see which direction they're going, and then adjust the scaling of their animation accordingly. So because the zombies are in a group, right? Zombies here is a group. Groups behave the same as arrays in JavaScript, which means we can iterate over them using the shorthand syntax in the for loop like this. We can say for every zombie of zombies, okay? So this is going to create a little temporary variable called z here that we can use inside the for loop to refer to all the zombies one at a time. Okay? So I'm using z here just because it's shorter. It's easier to type. So let's face the correct way, right? So we're going to check. We're going to say if. So how do we tell which way the zombie is going? Well, for the zombie, it's much easier than the player even, because all we have to do is look at its velocity, right? So we'll look at its x velocity, its speed x, and if it's greater than 0, it means it's moving right. So if that's the case, we'll say zombie.scale.x equals 1. And on the other hand, if the velocity is negative, we will set the scale on the x-axis to -1. If we set the scale on the y-axis, by the way, it means we would flip up or down the animation. But of course, this is not what we want to do. So now we can see our zombies are facing the correct way as they walk. Okay? Now, very quickly, they all scatter and leave the screen. Okay, so we could have code that we will eventually have code that will add more zombies over time to the game. But just to also make the game a little bit more challenging, once we've added a zombie, we're going to keep them around. We're going to get them to keep coming back. And the way we're going to do this is simply, as they walk off screen on one direction, we're going to bring them back on the other side of the screen so that they're always kind of looping around, and the screen will get busier and busier over time. Okay, so we're going to wrap the zombies around the edges of the screen. Okay, wrap around the edges of the screen. So we'll add a bit of code here that's going to check the zombie's position. So we'll use an if statement to say, look at the zombie's position, that's z.x. And if that's less than, let's say, -100, so we'll let them walk off screen a little bit, right? We'll say z.x is going to be equals to width plus 100. So if you move out the screen this way, you're going to teleport back on the other side a little bit to the right. So now zombies should be coming back from left to right. And we're going to do this in all directions. So we'll say if the x coordinate is greater than width plus 100, set the x coordinate to -100. So this is taking us from right to left. And just to save time here, we're going to copy paste, and we're going to do the same idea with y. Now, instead of width here, we're going to compare it with height. We're going to compare it with height. And here we're going to look at y. So now over time, oops, I gave this guy a bit of a knock. Over time, the zombies, they're going to stick around. Okay, so as they walk off screen, eventually they're going to come back. So I don't really make more zombies right now. I still have 10, but they are going to come back. Okay. All right. Awesome. Okay. And then what else could we do here as a behavior for the zombie? Now it's a little bit predictable the way that they walk. Like since we're in this section over here, let's add a little bit of randomness to this. So we'll say, okay, let's throw a random number. We'll pick a random number between 0 and 1. Okay? And if that's less than 0.01, which is basically 1%. So what we're saying here, this is going to happen. This if statement is going to happen 1% of the time. Okay? Seems like not very much, but don't forget we draw 60 frames per second, so it's going to do that test quite often. So 1% of the time, we're going to say, okay, if that happens, so we'll have these little random events. Let's go and mix up the zombie's velocity. Okay? There's other things we could do. We'll just make it random. Okay? We're not going to try to follow the player. That's too advanced for this game. We'll just say 1% of the time, right? In every frame, there's a chance that the zombie is going to randomly change its speed just to keep us on edge a little bit and make the game a bit less predictable. Right. So let's recap here what we have for a second. So we've created a sprite for the player, right? We've created a group for the zombies. We created 2 animation sequences. And to make our lives easier, we made an image sequence function that allows us to give some input, some file names and number of frames, and that builds up the array, the image sequence array for us, so we don't have to do it by hand, just to save time. And then we attach these animation sequences to our sprites so that we don't have to always draw sprites as basic geometric shapes. They can be images, animated images. And then we have some basic behaviors for our objects. Okay? We have our player following the mouse, and we have the zombies that are just kind of like walking around by themselves. Okay? And currently, like the zombies, they can't overlap one another. Right? So if they collide, you notice they're going to bump into each other and turn around. Oops, no, don't mind me bumping the zombies. That's not going to happen anyways in the final game, because as soon as we touch a zombie, we're going to be game over. Okay. So we could leave it like this. If we wanted zombies to be able to overlap with each other's, we could say in the beginning here, we could say zombies overlaps with zombies. Okay, so the overlaps command allows you to basically turn off collisions. And now the zombies are actually able to don't collide with one another. They can kind of overlap with each other. I'm not sure which version I prefer more, but for now, maybe I'll just to show you that we could do this with groups, right? So this is to basically turn off collision between zombies. Okay. Let's put that as an optional thing. So if you have a group, you can give it the group as the input here, and it's going to apply to every other object in that group, right? So it applies between all of them. But of course now they can still collide with the player. And by the way, the reason some of these zombies just go kind of a little bit crazy is that as my mouse goes in and out of the screen here, sometimes if I kind of go over there and then come back in here, the velocity vector added to my character is huge, right? You can see it's moving over, and then that causes a lot of force when we bump into other objects. We'll fix that in the next video as we refine our game mechanics. So at this stage, now that we have this, right, we have all the ingredients in place so that we can start to talk about programming an actual game, right? So what's a game? Well, a game can be as simple as, just something you have to do. So we have mechanics. So here the mechanics are we're trying to dodge the zombies. If we collide with them, right? If our collision boxes overlap, we're going to be in trouble. If a zombie touches us, we die. And we know how well we're doing because we're going to have a score. We're going to have a score that's going to count up every time. Eventually, we add more zombies to the screen, and we'll be able to try to beat our score. Okay. So we have to have this sense of progression. In other words, we want to be able to start with an introductory screen, go into the actual game, and if we detect we're game over, we want to change what we're doing. We want to display a different message and show that to the player. So we're going to need to have a little bit of structure in our program to have this kind of sequence where we go from point A to point B to point C. So this layer of adding the mechanics and the sequence, we're going to talk about in the next video. But yeah, now that we've set the stage, that we have the objects in place, our job as the programmer is going to be to write all the glue code, right? The code that's going to determine what is the logic of the game. And I'll see you in the next video to talk about this.